All right, we're back for the second part of the video, and on this one what we're going to look at is we're going to look at a special group of right triangles, and these are called Pythagorean triples. All right, Pythagorean triples are basically right triangles that have integer values for all the sides. And there's a couple of families that we're really going to focus on. The first is going to be a 3, 4, 5. All right, this is kind of an old standard. This was something that used to be used a fair amount in carpentry. You could have a rope with basically, as we go through there, so 3, 4, and 5 is going to be 12, so 12 segments on it. And then if you formed a triangle with that rope, you would be guaranteed a right angle in the corner because it was 3, 4, and 5 as we went around it. Another one is going to be 5, 12, 13. And then the last one that we're going to talk about is a 7, 24, 25. Now, there are plenty of other triples. If you look online and you take a look for Pythagorean triples, you'll see other ones with much higher values than these. But these are really the three that we kind of keep focus on in here. And mainly, to be honest, the 3, 4, 5 is the biggie. All right, 3, 4, 5 is the one that I tend to remember. The others, I usually just use Pythagorean theorem. All right, it's important to remember that today is all about a shortcut for this part. All right, Pythagorean theorem still stands, and all of the problems in this section you could solve with Pythagorean theorem. Pythagorean triples, if you recognize them, are really just a shortcut. But they do come up quite a bit in your Algebra 2 and Pre-Calc class, particularly Pre-Calc. So if you know them, it can save you some serious time. All right, now one other thing to remember, that if you do have a Pythagorean triple, like a 3, 4, 5, all right, if you take all of those sides and you multiply it by some constant, that's going to result in a similar triangle, because that proportion between the ratio between the bigger triangle and the smaller triangle is going to be whatever that thing that we multiplied by was. All right, so when we look at this, if we have one triple, we really get a whole family of them going forward. So 3, 4, 5 would also be like a 6, 8, 10, a 9, 12, 15, or so on. All right, so now the way that we tend to use this is, for example, in like number 1 here. All right, I've got 20 and 52. All right, and we know 20 is going to be 4 times 5. 52 is also divisible by 4. It's 4 times 13. So if I remember my triples, I've got a 5, 12, 13. All right, and the one thing that I want to verify is I want to verify that that 13 is on the hypotenuse. Sometimes people fall into a trap because they'll notice that, like, they'll see a 5 and a 13, but it won't be a leg and a hypotenuse. It'll be 2 legs. And then this falls apart because that longest one has to be the hypotenuse. All right, so this does fit that mold of a 5 and a 13. So that means the missing piece is the 12. Now, 12 times 4 is 48. So we end up with a 48 on this side. All right, because we're doing this side's 5 times 4. This side's 12 times 4. And that side is going to be 13 times 4. So it's a 5, 12, 13 that's been scaled up by 4. All right, so if I look at the next one, these we've got an 18 and a 24 for two sides that are given. Both of those numbers are divisible by 6. So 18 is 6 times 3, 24 is 6 times 4. So if I think of my triples, I know there's a 3, 4, 5 triple. All right, so I've got the 3 and the 4. They are the shorter two, and there are legs, so we're in good shape there. It's scaled up by a factor of 6. So I know in the family this last side is the 5 side. So I'm going to do 6 times 5, which is going to be 30. All right, so the hypotenuse of this is 30. Now, while I say this, it's a handy little trick. If you practice it and you get the hang of it, it can speed up and save you some time. But on the flip side, you could always just go 18 squared plus 24 squared equals x squared. Clean it up, and you'll get right back to the same answer of 30. All right, so this is really a shortcut option more than anything else. All right, so a couple to practice with here. This first one, you've got 32 and 24 on those sides. 8 goes into both of those, so you've got 8 times 3, 8 times 4, and that would leave us on this last side, since it's a 3, 4, 5, 8 times 5, which is 40. So x is 40. All right, this next one, 9 and 15 are both divisible by 3. So So I have 3 times 3 and 3 times 5. That 5's on the hypotenuse, so we're 3, 4, 5. So this last side is 3 times 4. So y is going to be 12. All right, if I jump over to the next one, I've got 28 and 35, both divisible by 7. So I've got 7 times 4 and 7 times 5, which means that last leg has got to be a 7 times 3. All right, so z is 21. All right, and that takes us through basically Pythagorean triples. Now there's a couple more examples. Try these, see what you think, and then come back into the video and watch the solutions. All right, so if you want to check these out, we've got our solutions here. You've got the first one was a 7, 24, 25, so P is going to be 72. The next one was a 5, 12, 13. Easiest way here was actually to switch it to fractions with a common denominator. Just makes it a little easier to see that 5, 12 pattern, which gives you the 13 for the hypotenuse. So we get 13 fourths. And then the last one was a 3, 4, 5. And we ended up with an 8 root 3 for that last side. All right, so I hope that helps with Pythagorean theorems. The next section that we're going to come back to is dealing with reducing a triangle. All right, principle of reduced triangle. We've actually kind of been using that all along through our triples, but it's a way to kind of shrink the triangle down, find a solution with more manageable numbers, and then come back and finish out the problem by scaling it back up at the end. All right, so I'll be back in the third video, and we'll talk through that.